Imagine your Cadence workers are being incorrectly downscaled, causing workflow delays and incidents. Today, I'll show you how to solve this with intelligent autoscaling. Hello, and welcome back to the channel. My name is Kevin Burns, and I'm a developer advocate here at Uber. And today we have a really cool demo of a new feature in the Go client, worker autoscaling. This feature came about from a real world problem here at Uber, and business functions were affected. Scheduled workflows, transactions, order processing were affected. The incident root cause was dynamic compute was incorrectly downscaling Cadence workers due to low CPU utilization. With real world business effects, workflow processing delays, service disruptions, and customer-facing issues. Through root cause analysis, we found out that static worker configurations, there wasn't a one-size-fit-all approach that worked for every use case. Causing low CPU utilization, targets were set to 10% versus the recommended 45%. Imbalanced task lists caused some to be over-provisioned, meaning there was lots of empty polls, while other task lists were starving. Accompanying this feature, we have a new article in the Cadence docs titled From Manual Tuning to Zero Config, the Autoscaler that Eliminates Cadence Scaling Headaches. And here at the top, we have some dashboards from production where we turn the autoscaler on and look how we were limping along at 10% CPU utilization, turned the autoscaler on, and it jumped right in that nice range around 45%. At the same time, at first, the worker instance count jumped up a little bit, about 10%, but then after a day fell another 50%, which could have some real world impact in saving compute resources. On the right side here, we'll show you how to get started. It's as simple in your worker options as just turning auto scaling on. If you're transitioning from a previous setup where you would set separately your max current activity and decision pollers, you can now just combine them into one. We just talk about pollers, an initial count, a minimum count, and a maximum count. And we'll show this all in the sample. In the How to Get Started section, we have a link to our interactive sample that I'm going to demo for you right now. The major feature of this sample is it has built-in load generation, real-time metrics collection, and monitoring dashboards so we can see the autoscaler in action. So let's open it. For this sample, you need to have the latest version of the Cadence server that will have the new dashboards to monitor the worker autoscaling, and also to turn autoscaling on the server side. If we navigate here, GitHub, to the root README, you can just follow this link to the Cadence server and get the latest. I've already gotten the latest, so I'm going to come down here and get the Docker compose command. So let's start the Cadence server. Let's check Docker desktop, make sure everything's up and running. Looks good. I've opened the sample in VS Code, and if we go to Command Advanced autoscaling and monitoring. Here's our sample. First place to go is the README. And we want to start the worker. And then we're going to verify that our endpoint, our Prometheus endpoint, is ready for scraping. So let's open up a couple terminal windows. The first one I'll call worker. The second one will be where we trigger our workflows from. So we'll call it trigger. And let's first make sure the binaries are built. We'll run the make. Okay, now everything is built, so let's start our worker. Just copy this start worker command. And it's running. I've opened up Docker Desktop. We'll use the shortcuts here to open up 3 web clients that we're going to use: Grafana, Prometheus, and Cadence Web. The first one we're going to open is Prometheus. And we just want to check on the status of our endpoint in our sample. And it's up and running. The next one we're going to open up is Cadence Web. We'll be using that later. And the third one is Grafana. We're going to go up here to Dashboards, select the Cadence Client dashboard. And the dashboards we're interested in are the concurrency ones. You can see they have no data until we select a domain, and we're going to be using the default domain. Let's zoom in to like the last 15 minutes. Set a 5-second refresh. You can see our polars have gone down from 4 to 2. The initial count was 4, and since there's no workflows running, it's scaled down to 2. The next part of our sample I want to explore is the configuration. So in the config directory, we have an autoscaling YAML file. In the autoscaling section, you'll see we had an initial polar count of 4 and a minimum count of 2, and that's why we saw the downscaling from 4 to 2, as we're not running any workflows at the time. Now, the fun part of this demo is the workload simulation settings. And we have some fun little load generation. You can select how many workflows you want to run. You run the trigger, what the delay between each workflow is. And then we have our workflow will start n number of activities per workflow. And then there'll be, and the default is 30 here. Inside the activities, we have a fun little random sleep time in between this range. This is all in milliseconds, so it's set up to randomly sleep between 1 and 6 seconds. We're now ready to run some of these simulations. If you go to the README, I've included some example load patterns. The default, gradual ramp up, burst load, and sustain load. So let's first run the gradual ramp up. Let's run the script to generate a load. First need to switch directories. And then run the trigger. You can see the workflow starting. There'll be 10 of them, 10 autoscaling workflows with 30 activities each. Let's check Cadence Web. And we can see the workflows already completed. Let's go to Grafana, and we can see the activity worker scaled up to 8 workers with very little impact on the decision worker. We observe the activity polar has scaled back down due to inactivity. Now let's try the burst load. 25 workflows with no delay in between workflows starting. And 60, a total of 1,500 total activities. Let's trigger it. Let's go to Grafana and observe what happens. The activity polar is scaled up to 8 polars. The decision worker has scaled up to 8. And after 2 minutes, we've scaled back down to 2 polars for both the activity and the decision worker. And finally, let's look at the sustained load. 50 workflows, 2-second delay between workflows, and 100 activities per workflow. Trigger that. Let's go back to Grafana. Activity polar is scaled up to 8. And the decision polar up to 4. Now the decision polar has scaled up to 8. Let's check if our workflows have completed. They're still running. And both of our polars are back down to 2. And you can see we had a lot. Our sustained load took the full 5 minutes. I hope you enjoyed this demo of our exciting new Go client feature. If you did, let us know by liking and subscribing below. If you have any questions, please read the full documentation or comment below. Stay tuned for our next video. Till then, bye-bye.